We will now begin our fourth technical session at Explosafe 2016. While extraordinary products and unique services still afford a competitive advantage, the one advantage that stands the test of time is people, says Mark Salisbury. On that note, please welcome our chairperson for this session, Sri Rakesh Kumar from Indian Explosives Private Limited. I request Sri Rakesh Kumar to come to the dais to chair our first technical session on aspects of plant design and role of HR function. I would request Mr. A.K. Jain from Solar Industries India Limited to welcome Sri Rakesh Kumar with a floral bouquet, please. Sri Rakesh Kumar is a 2001 batch graduate in mechanical engineering from Karnataka Regional Engineering College, Surathkal. He has completed a year course, Executive Program for Young Professionals from Indian Institute of Management, Kolkata. He is a 7-time winner of Start Performer Award for Innovation in Sterlite Optical Technologies Limited, Sterlite Vedanta, in his tenure of first 6 years of professional experience. He has filed 2 patents for innovation in optical fiber process technology. He has over 15 years of experience in operations, projects, engineering, maintenance, and utilities. Currently, he is working with Orica Gomia. Please give Mr. Rakesh Kumar a round of applause. Thank you, Mr. Kumar. I would now call upon our speakers for the first session. Please welcome with me Sri M.D. Trout from Trout Consulting, South Africa. I would request Dr. Srinivas Rao from Premier Explosives Limited to welcome Sri M.D. Trout with a floral bouquet, please. Now, I would like to request Dr. M.K. Patel, IDL Explosives Limited, Rourkela, to come up to the dais as our next speaker for the first technical session for today. I would also request Mr. C. Paradkar from SBL Energies Limited to welcome Dr. M.K. Patel. Our next speaker for today is Dr. Prabhanjan Thakur, Center for Fire Explosives and Environment Safety, DRDO, Delhi. I would request Mr. S. Mohan Rao, CDET Explosives Industries, to welcome Dr. Prabhanjan Thakur with a floral bouquet. And now I request Sri Sayanjit Mitra, Associated Engineers India, Nagpur, to come up to the dais as our speaker for this session. And I request Mr. Kundan Jaiswal, Orient Explosives, to welcome Sri Mitra with a floral bouquet, please. Thank you, Sri Rakesh Kumar, for being the chairperson of this first session and the speakers. I would now request the chairperson, Sri Rakesh Kumar, Indian Explosives Private Limited, to chair this session for Explosafe 2016 on the aspects of plant design and role of HR function.
Good morning, ladies and gentlemen. So today, first I would like to once again thanks to Explosive Manufacturer Welfare Associations and the PESO organizations to give me the opportunity to chair the technical sessions. And I would like to start the sessions with yesterday reflections. In the morning inaugurations functions, the three gentlemen, Dr. Kamal, Mr. Mishra, Mr. B.P. Singh, and Mr. Vijay Nayak has given a very good thoughts on the importance of the safety, importance of the systems, growth of the coal market in the near futures, and the requirement of the manufacturing standards, safety standards in the explosive field. Then coming to the technical sessions, we have started with the sessions with the development in the explosive field. Then we moved on to the hazards. What are the hazard scenario we are facing with the manufacturing of the commercial explosive? And the last sessions was very informative and educative related to the incident management. So thank you all the gentlemen who has given us today deep thoughts on these technical subjects. Now today's sessions is very, very important with respect to the explosive manufacturing. So we are going to start the sessions with the two important pillars. One is the aspect of the plant designs, another is the importance of the HR role in the explosive manufacturing. As we learned in a study sessions, in the last session doing the incident management and the second last session in hazard scenario in the explosive manufacturing, the importance of the plant design is very, very important. It means the plant designs starting from the selection of the site layout, the building layout, the construction of the buildings, flooring conditions, then machine design, machine layout, and finally decontamination, burning ground, all the stuffs. All the stuffs are very, very important. So I know all the speakers are sitting around me are very, very experienced in their field. So I will start the sessions. The first topics of this today's session is aspect of the explosive plant designs. And so that is presented by Mr. M.D. Trout. And Mr. M.D. Trout holds a National Advanced Technical Certificate in Chemistry, Physics, and Mathematics, and Higher Diploma in Chemistry in the Industrial Administration from Capitan. And since 2001, he established his own consultancy, M.D. Trout Consultancy, and he's working as a consultant in the projects and change management in the explosive and the chemical industries. Now I hand over to Mr. M.D. Trout for sharing his experience on the subject of aspect of the explosive plant design from his vast experience. Welcome, Mr. M.D. Trout.
Thank you very much.
And the role, for a very effective role, I think everybody is knowing, so I will request every speaker to stick with the timeline. So after 10 minutes, I will give the first ring. After 12 minutes, I will give the second ring. And after 2 minutes, and at a time of 40 minutes, I'll give a call.
I'm not sure I can remember all that, but I'll listen to the bells. Thank you. I'll try and keep to the best I can. It's really a privilege and pleasure for me to be in your country this morning. And I thank, first of all, Mr. Chair, thank you for your introduction, my co-delegates on the rostrum, and then every one of you present here this morning. And I also would like to thank the two associations involved with the seminar, the EMWA and PESO. Thank you so much for having me here. The talk I'm going to give this morning is not rocket science. In fact, it's a very basic talk which has been based on the fact that I've been around for a little while, and I've seen things which to many people may be obvious and to some not so obvious. And a lot of the experience I've gained is either through manufacturing, but by and large of late, I've been involved with the cleaning up, the remediation of many explosives contaminated sites around the world, and in particular in South Africa. And so a lot of what I'm saying will be, in fact, based on some of those findings and some of the reflections on if it had been done differently, how much easier and cheaper and less and more cost-effective it would have been. My talk is covered in a few topics, the one being the initial site selection, the way in which the plant would be laid out, the building design, machinery design, the design of the infrastructure, and then just a little bit of wrap-up, because nothing is complete without documentation. So in essence, that's going to be the way I'm going to cover it. If you have the privilege of being able to start a new plant on a new site, you do it very differently than from trying to establish a new facility on an old site. So a pristine site would come as it is, and it would be uncontaminated. One that's been running for a number of years, and you have some very old plants. When I say old in inverted commas, because that does not mean that old is bad. In fact, the talk this morning actually tries to indicate to you that old sometimes comes with experience. So if you have this facility that you're going to do a new project on, a new site or a new area within your own site, there are a number of issues that one needs to look at. Specifically, I mentioned a few here, like the geology of the site, the hydrogeology, the hydrology itself, and the aquifer classification. In other words, the sort of water, groundwater you have, is it good for drinking, is it not, that's what I mean by that. The ecological receptors, really, what is your water structures and aquifer going to impact upon? And then, of course, surface water features. So once you've got this information together, you then have a concept of what your site looks like and what you're likely to impact upon. The key impacts that are possible in our sort of business are, in fact, things like nitrates and of course, normal explosives. But even ammonium nitrate, which classifies as an explosive as well as a fertilizer, they all come with their own baggage. So I mentioned a few there, like in many plants around the world, we used to use mercury fulminate, would you believe, instead of the things like the azides and the NHNs and those sort of things of late. So they all bring their own baggage. The key to the contamination or the contaminant that is present on your site would then determine what impact that those particular contaminants would have on either your primary aquifer or your surface water. This is an example of an ammonium nitrate plant that that was at a the groundwater around the plant had very high nitrate levels of the order of 1,000 parts per million or 1,000 milligrams per liter. And that water body was only 2 meters below the ground. It managed to get into the water stream, which is on your right. And you can see the establishment of some of the luscious growth because of the high nitrates. But in addition to this particular drain or channel fed into the next area, which was a lake on the site itself. And with high nitrates and phosphates, of course, you end up with this algae growth. And in fact, in some cases, it's cyanoalgae, which is in fact a poisonous algae, and its name tells the story because it has a cyanide compound attached to it. So this was what the lake looked like, and this was the result. This is on a working site. And that required then for that lake to be desludged, and in fact, it cost the company at the time, in your equivalent, something of the order of 30 to 35 million rupees. That would have been the cost to just get this back into a more pristine condition. This is just a photograph of a site where traditionally on old sites, people used to bury their waste because it was seen as unsafe to send the waste off-site. Now you can imagine what this is going to do to an underground water stream if it started leaching out in high rainfall area, and this is a high rainfall area. The rainfall in this particular area was of the order of 800 to 1,000 millimeters a year. Okay, I'll move on to the next section of the talk, and that is plant layout. And again, as I said earlier on, it's not rocket science. Basic things like tracks for running trolleys or vehicles on, and so on. We look at these things and we design them almost without really thinking what's going to happen on those tracks. Trolleys may have to pass one another, whatever the case may be. People will be walking there, road vehicles may be going there. And inevitably we build them and they're too narrow. And the upshot of the narrow trolley is the fact that quite often the trolley would go off the tracks, it would go onto the dirty surfaces, it'll pick up dirt, take it into the explosives buildings and so on. Personnel can't pass one another easily, so they walk into the dirt and back onto the so-called clean walkway. The other part of plant layout that I want to allude to is that of stormwater. Quite often we end up with stormwater in our effluent systems. So you have rainwater coming into what is contaminated water into a labyrinth or a sump, and that then inevitably overflows or overfills and then contaminates the surrounding area. We plant vegetation on our sites, to improve the aesthetic look of the site, but also sometimes to give shade, or in the old days we used to plant trees so it could absorb the shock in the case of a major incident. But of course it comes with its baggage because the roots and these sort of things, they affect pathways, and this is kind of just a very rough picture of what trees and things. You start with a good intention and then you end up with this sort of mess. The key, of course, is when you're thinking about enriching and beautifying your area, think about the type of vegetation that you're going to plant and whether it's maintainable and so on and so forth. It's essential that when one is looking at a plant that you try to keep all your services and service lines like steam, air, or water, electricity above ground as much as you can. Simply because that way you can detect faults and it's easy to maintain. And it's something that we quite often lose sight of because we end up with underground effluent streams, underground pipes, underground services. And then when we get leaks and problems, A, it's difficult to get to, and B, we have the high risk of contaminating the area and the aquifer below it. On older plants it's even worse, because we've somehow or other lost the history of where the effluent lines and where the piping and the electrical lines and so on are. And I would make a strong suggestion that even on the older plants and even today, that it is worth your while to go and track and trace those lines right now and put them on new drawings so that you are building up a legacy for the future. Just as an example of feed lines above ground, and you can see that the spill around those lines, this is a diesel offloading facility. You can see that it's very visible. This is just a photograph of one we found. This was a nitric acid line which is buried underground, and it had been there for like 30 years. And it still had active nitric acid in it. You can see that from the NOx. This is just an example of how not to care for your above-ground facilities. If you can see it, then clean it and maintain it. Don't let it get like this. When one looks at building design, and particularly walls, bricks, concrete, asbestos, wood, you have a choice of many raw materials. And they each come with advantages and disadvantages. For instance, bricks are difficult to dispose of once you do any demolition work. And of course, in the event of an accident or an incident, they act as missiles. Asbestos is a regulatory problem, and the use in many countries has been banned. Plastics, when you burn them, you're getting either fluorine or chlorine or whatever, and you're getting things like dioxins and furans into the air. An example of a brick construction, this was a warehouse that housed ammonium nitrate. The walls had been clad with metal cladding, and when we took the cladding off, you can see on the bricks and the walls the ammonium nitrate that's still ingrained in it. This is a bend in a gutter, and I spoke about the way in which one designs things like trolley tracks and so on. Gutters, traditionally, where there's a bend in a gutter, you get spillages and you get contamination. This gutter had been decontaminated, it was clean, and we decided to do a secondary blast on it using an emulsion explosive, and this was the result of a clean gutter. A huge secondary explosion. When you get to this, materials of construction, there's always a decision as to whether your mound should be soft or hard. This is a reinforced mound, difficult to get rid of. Just this one, just a photograph of an incident where asbestos shrapnel got thrown for up to 300-400 meters. A well-constructed building, concrete roof, aluminium, partially for soft walls. A poor example of a building which had corrugated iron mild steel. Floors, again, you've got the choice as to how many floors, what type of floor to put into your building. This is a recipe for disaster. This is a trolley track running into a building, and you can see the cracks there. PETN ingrained in the actual walkway. An example of a good floor. Spoke about soft mounds, getting rid of a soft as opposed to a hard mount. Ventilation and ducting. This particular duct, it's exiting on a roof and it's contaminating the roof. There's no scrubbing system in this at all. And a very old machine, an idea packer, an NG, a dynamite packing machine. You'll see the materials of construction. This is ducting that was taken off like 10 years after the plant started because no one believed that the atmosphere was contaminated, and you can see the TNT in there. Okay, I'll gloss over this because it's probably something you know very well, but the engineering standards that you build your plant to are key. And things like the types of materials you use, but also the finish is very important.
Mr. Raut,
I'm with you.
2 more minutes time.
I'll be finished. I don't. Thank you, Mr. Jain. Thank you, but I will get done. This is an old DuPont shuttle. You can see the materials of construction again: aluminium, wood, and stainless steel. Good combination, and everything. You can see the nuts and bolts are sealed, and it's an example of a good idea. This is the opposite. This is a ball valve in a PTN line. And in principle, ball valves are not good when they trap explosives and they are friction type valves. I spoke about engineering. Nuts and bolts that are either long or short, they're not enough thread protruding. You can see the same example over here. And then I'm nearly finished, Mr. Chairman. The waste and effluent streams. We always regard waste and effluent as the toilets of the factory. Everybody sends all their rubbish to the burning ground, all their rubbish down the drain, and when we don't see it and it disappears down into the ground, that's done and dusted and we don't care anymore. And believe me, that's where over the last 18 months we've had 15 accidents reported to SAFEX on burning ground, only burning ground accidents or incidents. From an ancillary point of view, a plant point of view, many of our plants come with their own laboratories, their own laundries, their own decontamination facilities. And in that particular case, be aware that all those carry their own baggage. In one of these sites where I cleaned up a laboratory site, we had things like lithium and cadmium and mercury in large quantities. The lithium came from the lithium stearate used in plastic explosives, cadmium from normal chemicals used within the laboratory, and so on. Typical of burning ground waste, asbestos, and so on. These were found on a burning ground which was very old. You can see they were buried in approximately 45 because they still had the markings on them, copper detonators, and you can imagine what kind of issue this raised. Just in closing, I just want to acknowledge these particular companies that allowed me the photographs and so on. Sorry. And then also Solar Explosives for sponsoring my trip. Thank you very much.
Thank you, Mr. MD Trout. You had given a very good thoughts, starting from site selection. What are the factors? What are the factors we have considered during the site selections? Important steps you have given on the contaminations, which is very, very important stuff for the explosive manufacturer. We have to think about the environment when we are dealing with any raw material like the ammonium nitrates, TNT, and other good things, best things he has given about this, the practices, cleaning of the ductings, which is very, very important for the explosive manufacturer for understanding the requirement of the cleaning of the ducting, like where we are handling the TNT and the PTN, where lots of the fumes are getting generated. So thank you. Thank you for your wisdom and the experience which you have shared in front of all the explosive manufacturer and the other people associated with this. Thanks a lot, Mr. MD Raut. So now the second session, the second speaker will be Mr. M.K. Patel, and his topics of today's presentations is applications of integrated management system in implementations of the same operating procedures. And Regarding Mr. Manoj Kumar Patel, he is a postgraduate and gold medalist in inorganic chemistry and a PhD in environment chemistry from the NIT Rourkela. And he had about 75 publications in the journal related to the various development. And at present, he is working as assistant general manager in the Rourkela, works as an ideal explosive. Welcome.
Thank you. Good morning, everybody. This is about a case study of Ideal Explosives Limited. The topic is application of integrated management system, IMS, in implementing safe operating procedure. Now, basically, why IMS? And beginning with the end in mind, the objective of the IMS was to create a safe and accident-free work environment in manufacture of quality products in Ideal Explosives Limited. Now, any basis of any management system is PDCA cycle. Here, nothing more to say. We all know about plan, do, check, and act. Recognize an opportunity and plan a change. Test the change, carry out a small-scale study, review the test, analyze the results, and identify what we have learned. And in the act stage, if it is useful, implement it. If it is not useful, take a different course of action. So basically, it is creating an upward spiral of continuous improvement. Now, IMS basically is an amalgamation of many systems. And in our case, it is quality, environment, health, and safety. 9001, 2008, 14001, 2004, and OSAS 18001, 2007. Now, when we talk about the quality management system, we usually try to give a good product. But basically, the inputs what we think about is like either the raw materials or the services which we take into account for the internal business process, and then product or the services as the final output. So basically, we do not cover many of the inputs, and we consider output as only the final product. And in the process, like what we do is leave about an area of inputs and area of outputs. So when we talk about IMS, we talk about inputs as raw material, water, air, that is natural resources, recycled products, power, supplier-related products, and transportation, at least internally. And the output, finally we consider product as the output. And in the process, reusable waste, ill health, noise, accident, solid waste, liquid waste, gaseous emissions, water, byproduct. So when we consider about IMS, when we think that IMS as the system for running the industry, we consider so many outputs. And basically, it covers all the areas. Now, it's a case study of Ideal Explosives Limited. In the same one management system, we have covered 14 different locations, 8 plants, and 6 silo units. Typical characteristics, I will not be reading out this, I'll just be. But some of the features of IMS, how does it help actually in implementing a safe operating procedure, an accident-free environment, a good health environment, like policy statement, a single policy statement structure covering all relevant aspects in a generic way without unnecessary replication. This basically is the Apex manual for the entire organization. Then a manual, a single management manual describing the formal management arrangement unless specific stakeholder requirements such as licensing and regulations prohibit it. Entire manpower issues, not site-specific basis. Entire risk assessment, process controls and developed such that opportunities and all aspects of risk are simultaneously addressed. Documentation, management controls at company and project levels are defined in a single coherent set of documents, such as generic plan procedures, work instructions, and forms. For example, an event reporting form would cover any issues such as a complaint, personal, or environmental accidents. The database, reactive monitoring, covered in the single format. Monitoring, proactive monitoring, like audits, inspections, surveys, benchmarking, are managed together in a coherent way, effectively and efficiently. Change management, all sorts of change management, covered in the single document, single format. Management review process covers the entire set of activities and what needs to be done, even like things in Swachh Bharat. Risk assessment, aim to apply management tools and approaches generic way to achieve improvement, that is integrated risk assessment. Now the documents, this is what we have covered, and usually it is covered in an IMS system, is the Apex manual, the process manuals, the specification documents, standard operating procedures, work instructions, AI analysis, hazard identification and risk analysis, the legal register, and MSDS. Now, the IMS tree in ideal, Apex manual, which covers the entire, like 14 locations, 8 plants and 6 silo units, followed by the process manuals. And each process manual covers processes, sub-processes, share and stakeholder issues, manpower metrics, quality, health, environment, safety objectives for each process owners, emergency plan, communications and documentation. And coming over to the process, like when we have a process manual, we address like every department, every unit's like specification document, share and stakeholder issues, and quality, health, environment, safety issues. And in the specification document itself, we can see like work instructions, PPEs, MSDS, share and stakeholder issues, emergency plan, legal register. And in QHES, we have process safety, hazard identification, risk analysis on OHS issues, and in EMS, aspect impact analysis. Now, it's just an example of a PPE matrix for one particular unit. This is for R&D and quality assurance department. So, if any activity is going to be carried out in the department, inclusive of the plant inspection, how the PPE matrix has to be really covered, and we should be knowing about it. MSDS, it's all available. I will not go through the details. We do process safety audits, and this is basically done probably in all the structured organizations. 19 parameters starting from housekeeping to material storage, lifting tools and tackles, PPE compliances, MSDS, hazards communications, documentation, all aspects. And there are other areas of control which are like both external agencies as well as the internal agencies we do it. Fire risk assessment, due diligence for EHS issues, fast aiders training, and rescue training programs. These are all conducted by the external agencies, followed by safety audit, work permit system, pump safety training, mock drills, process safety audits are internally covered. Now, this is just an example. Last 6 years, how the training has been imparted to like workmen. This is about the health checkups, last 6 years. Internal audits we do carry out. And here, management review meeting, which follows internal audit, is cover all aspects of management system, considers points that have come up in the audits, and management programs, both for social corporate responsibility as well as internal. And in conclusion, like how did it help us? In the lagging indicators, we can see that 13,47,000 man-hours worked, fatality rate nil, lost time injury nil, medical treatment cases nil, fast aid cases 15, and road-related accidents, internal, external, nil. In the leading indicators, we had 29 training sessions, 12 safety audits, 8 external audits, 11 near-miss reports, 12 suggestions, SHE suggestions, and 2 mock drills. In conclusion, like what we achieved, solid waste handling, both hazardous as well as non-hazardous, separately and treated separately. Burning station, controlled burning and engineering landfilling by Ramki. Water consumption came down by 20% compared to the previous year, and this is going on. Every year it's coming down. Secondary containments, reuse of water, condensate water, affluent water monitoring, groundwater monitoring, and community initiatives. Thank you.
Thank you, Mr. M.K. Patel. Yes, much before times. You have completed your presentations within 10 minutes. Thank you for that. And within 10 minutes, you have given a very good thoughts on the integrated management systems of 3 standards, ISO 9001, 14001, and 18001. And every standards you have given, what are the steps we have to follow, and what are the checklists we have to follow, and what are the benefits you have got in the organizations. So thank you for sharing your experience to all the explosive manufacturers which are sitting here. And I will request everybody to just take the input from Mr. M.K. Patel and try to get some takeaway from these presentations and review our integrated management systems in our factory. Thank you, Mr. M.K. Patel. Now, our the second speaker is, third speaker for this session is Mr. Prabhanjan Thakur, and he passed in 2003 as a mechanical engineer from the BIT Sindri, and after that he joined in DRDO, and he has a 12 years of working in DRDO. So now I will request Mr. Prabhanjan Thakur to give the presentations. His topics for the presentation is high performance multi-compartment explosive storage structure.
Respected Chairman, Mr. Rakesh Kumar, sitting delegates on the dais, and the delegates from various organizations and peer scholars. A warm good morning to all of you. I am going to present on high performance multi-compartmented explosive storage structure. Today, the problem of Army, all the services, I mean Army, Navy, and Air Force, is to accommodate maximum ammunition in the minimum land area. And in that direction, this project has been taken, and design has been carried out, and validation trial was conducted. Initially, all the conventional magazines were built using bricks and RCC, reinforced cement concrete. And in that, the quantity distances, I mean the storage inside quantity distance, that was very, very high. That is the inter-magazine separation distance. Whenever you are constructing 2 magazines, you must keep some distance of separation depending on the quantity of storage. That is why it is called quantity distance. And that was 2.4 W cube root in all the conventional magazines. And that is why we are requiring much of the land area. The challenge was to decrease the separation distance so that we can accommodate maximum ammunition in the minimum land area. And in that direction, our laboratory, Center for Fire, Explosive and Environment Safety, taken up so many projects. The first project was taken for LRC igloo. The new material is LRC, last reinforced cement concrete. It is basically, in RCC, we are lacing with 10 to 12 mm dia wire, steel wire, so that the ductility of the construction material increases, and that is why the energy absorption increases and less propagation of blast effect in the nearby regions. So that decreased the inter-magazine separation distances by 5 times. Instead of 2.4 W cube root, it has been decreased to 0.5 W cube root, and it resulted into much more saving of the land area. Then after, the second project was taken on unit risk principle, in which there was a multi-compartmented storage structure. If there will be initiation in one compartment, there should not be any effect in the nearby compartment. And it is also a special type of this high performance magazine, unit risk principle magazine with greater risk. Okay. Now, the first thing is, what is quantity distances? Whenever you are constructing any magazine, it must be separated from the nearby magazine by a minimum separation distance, so that there should be less damage to the persons working involved in that magazine, to the ammunitions stored in that magazine. And it depends on the quantity of the explosive stored. That is why it is called quantity distance. And there are two types of quantity distances basically. One is inside quantity distance and other one is outside quantity distance. The inside quantity distances are, in the depot area, the distance between two storage units and the distance between storage and process units, or two process units. Distance between two storage units is called SIQD, storage inside quantity distance, and the distance between storage and process units, or between two process units, is called PIQD, process inside quantity distance. Apart from that, there are two OQDs, outside quantity distance. One is PTRD, public traffic route distance, and the second one is inhabited building distance. This inhabited building distance is the distance of the magazine from the nearby population. So it must be very, very high, so that there should be no any damage to the inhabited buildings present in the nearby region. And the expected values of our pressure are, at SIQD it is 1.81 bar, and PIQD 0.27, PTRD 0.09 bar, and IBD 0.05 bar. And the scale distance, as I told earlier also, in the case of IBD it is maximum 22.2, because we need maximum safety at IBD. So these are as per the regulations, international regulation, and it has been included in our state regulation also, and it is accepted internationally. Okay. And all these are mentioned in the Orange Book issued by United Nations. And at IVD, there is a second criteria apart from pressure is lethal fragments, density of lethal fragment. A lethal fragment, if a fragment is having 79 joule of energy or more, it is called a lethal fragment, and its density should not increase 1 in 56 square meter. At this particular value, we are having a risk of 1%. If a person is present in the IVD area and with this pressure and with this density of the lethal fragment, persons is 99% safe. There is probability of 1% casualty. Now, what is the advantage of multi-compartmented storage? Initially, the storage compartments are not compartmented because we wanted to decrease the inter-magazine separation distance. But in that case, in LRC Igloo, the IVD was not decreased significantly. That is why if you are dividing the total storage into number of compartments, the total, the quantity distance will be as per the storage of unit compartment. And that is why suppose you have to accommodate 50 ton in a building. You can divide it into 10 compartments, and whatever distance now you will require, that will be as per 5 ton. So this is the biggest benefit. We are going to decrease inhabited building distance using this type of design. We can compare this 50 ton NEC capacity non-compartmented structure and that 10 compartmented structure of 5 ton NEC capacity per compartment. The IVD has been decreased from 820 to 380. So almost 60% decrease is there. If you will increase the number of compartments, it will decrease furthermore. Now, the first thing is that whenever there is initiation of explosive in any compartment, we don't want that the nearby compartment explosive should initiate. And how this initiation takes place. There are three criteria. One is, if it is heated by high velocity fragment, it will initiate. The second one is due to high pressure, and third one is due to high temperature. So the fragment is generally generated due to spalling and scabbing, and as per the NATO safety principles manual, if a fragment is having a velocity less than 50 meters per second, the impulse is the guiding criteria, and if the impulse is greater than 100 Newton second, in that case, it can initiate the nearby ammunition. So it should not achieve that much impulse. And if the velocity is greater than 50 meters per second, the kinetic energy should not increase 2500 joules. So these are we want to decrease the kinetic energy as well as the momentum of the fragment. So even if it will hit, it will not initiate the ammunition, and there should not be any sympathetic detonation in the nearby compartment. At the same time, the pressure criteria is, for TNT, it is around 90 kilobar, which can never be achieved. So it is not significant for us. And temperature, it should not increase the self-initiation temperature. Now, what we want, that there should not be collision of the two blast effects. If there is initiation in one compartment, the other compartment should not initiate simultaneously. In that case, the damage will be multiplied. And in this picture, it has been shown that during that period, if the second explosion takes place, how much the damage is increasing. And if after that duration, when the positive duration of load is passing, then if the second blast takes place, there is less damage. So in this magazine, high performance magazine, we have our design criteria was that there may be delayed detonation, but there should not be any sympathetic detonation. If there is sympathetic detonation, it must be delayed by certain period. In our case, it was 90 milliseconds. By 90 milliseconds, the effect of the first explosion will be totally out, and then after, if there will be second explosion, then there will be less damage. So this type of magazine is basically suitable to the forward areas where there is really much scarcity of the land, and we have to compromise with the risk, with the safety, and the nearby compartment may not be safe, but there will be no any sympathetic detonation before the certain delayed period in the nearby magazine. This concept already I have explained, that the separation of the explosive storage into compartments in a structure in such a manner that initiation of explosive in one compartment does not result in sympathetic detonation in the adjacent compartment. This is the layout of the HPM structure. You can see we designed 3 compartmented explosive storage structure, and it was separated. The 2 compartments were separated by non-propagating sandwich walls, non-propagation blast suppression walls, and it was composed of air gap and sand filling. And sand filling was done in Hume pipes so that maximum energy absorption should be there, and sand was basically to arrest all the lethal fragments. And air is a better attenuating medium. But what happened that we proposed 2 designs. One is sand, and another one is air, sand, air. And during the design process, we got almost the same results, same pressure attenuation in both the designs. That is why we constructed 2 acceptor compartments, and in the donor compartment, the size of all the compartments was 10 into 8 into 3.6 meter, and in the donor compartment, 5 ton of NEC was initiated intentionally, and we assessed the effects on the acceptor compartments. These are the advantages already explained. And this is the actual constructed explosive storage structure. The central compartment is the donor compartment, and all type of instrumentations were provided to measure the blast overpressure, lethal fragments, that ground vibration, and that peak particle velocity. So these are the parameters which were measured, and a strain inside the acceptor compartments also, that either it is in the acceptable limit, that the compartment can be reused or not. And fragment distribution was analyzed by the fragment team, debris collection and analysis team. This is the stacking, and this is the instrumentation inside the acceptor compartment. And after the blast, you can see that the central compartment goes off, and there was significant damage in the partition wall facing the central compartment. And there is much more reduction in the pressure values. We can see that at SIQD, as per the stack principle, the pressure expected is 1.81 bar, and it was observed at 1.18 bar. And at OQD, we can say that 20% reduction is there. Instead of 0.05 bar, it was 0.04 bar. Similarly to the other PIQD and PTR also. And due to this percentage reduction as per SPM design, we can say that almost, 20 to 30% reduction in the quantity distance. And if you are constructing this multi-compartment storage structure, the IVD will be decreased by almost 60 to 70%. So finally, we can conclude that there were two types of non-blast propagation walls: sand, air, and air, sand, air. As per our design, both were in close agreement. But after conducting the validation trial, the sand, air, sand was proved to be better one. The pressure recorded during the trial at SIQD, PIQD, PTR, and OQD in all directions were substantially lower than the values as per stack regulation. And the reduction in quantity distance was directional and was over and above the reduction resulting from the limitation of maximum credible event to 5 ton NEC. Because instead of 50 ton, the maximum credible event is 5 ton if you are going to construct 10 compartmented structure. So that is why there is much reduction in the quantity distances and much saving in the land area. I would like to show the video of the validation trial. Please. This is the layout, actual constructed explosive storage building. This is the stacking and sensors, pencil probe. This is the recording room. It is underground room and application of detonator. This is another view. Recovery of the ammunition kept in the acceptor compartment. Thank you for patiently listening. Dhanyavad.
Thank you, Dr. Thakur, for giving the very technical thoughts on the design of the constructions of the magazines, construction of the compartmental stores with the new technologies. So this will be a new learning for us. So I will request all the manufacturer. Sometimes we are struggling in getting the safety distance. So by applying the new HPM design, this will give some new thoughts while constructing the new buildings and the new construction magazines. Now, the next presenter, a speaker for the today's sessions is Mr. Sanjit Mitra, and his topics of presentations will be safety enhancement in BMD with PLC. And about Mr. Mitra, he is a chemical engineer along with the MBA, and he has a wide experience in the field of fabrications of various reactor, portable explosive manufacturing plants, and BMD vehicles. So over to Mr. Mitra.
Good morning, everybody. I'm firstly thankful to EMWA, members of the PESO, and the organizing committee for providing me an opportunity to present my paper in this August gathering. Moving on, my topic for discussion is safety enhancement in BMD with PLC. First, I'll briefly touch what is a BMD and how it works. Then I'll move with what are the advantages of having a PLC. As everybody knows, the bulk milk delivery unit carries non-explosives from the plant, mixes it at the site, that is the mines, and the residual amount is taken back in non-explosive form. It composed of chassis and the processing module. What is the difference between a standard automobile and a BMD? In a standard automobile, when we start the engine and apply the gear and accelerate, it moves. In a BMD, we start the engine and engage the PTO. The power is shifted to the hydraulic motor, and from the motor, the entire system runs. Here I have shown from the hydraulic tank, the hydraulic oil goes to the hydraulic pump. The pump derives its drive from the engine, and from the hydraulic pump it goes to the valves, from the valves to the motor, and in turn the motor rotates the hose reel, the auger, and the pumps. I have already told the BMD utility. Now these are the broad classification of BMD types which are used worldwide. Moving on to the PLC. What advantages does PLC have? The advantage of having PLC are threefold. First, it improves the system performance, that is, the formulation is improved and there are no blasting failures, I mean to say. The second is eliminating the human error, and third is eliminating the system error, that is the equipment error. Now how this is happening, I will explain. This is a standard cabin fitted HMI through which the operator can sit in the cabin itself and operate. It has got three buttons. One is the start button, one is the stop button, and one is the reset button. This is actually the PLC panel which is fitted in the cabin. Now what does it do, the PLC, what does it have? A PLC, the heart of the PLC is the PID. Now what is a PID? A PID is a proportional integral derivative controller. In simple language, if I say an equation D is comprises of A plus B plus C. Now A is the proportional term, B is the integral term, and C is the derivative term. Each one has its own function in improving the formulation. What the proportional term does, it reduces the error. The integral term, what it does, it eliminates the errors which have happened previously. And what the derivative term does, it predicts the future and brings the system into steady state. Now I will go into detail once we go. This is actually the equation, so nothing like this. Now what is the proportional term? The proportional term produces an output value that is proportional to the current error value. The second meaning is a high proportional gain results in large change in output for a given change in error. What does this mean actually? Here I have taken a discharge rate of 250 kg per minute. The formulation is 94% emulsion, that is 235 kgs, 4% GA, that is 10 kgs, and 2% water, that is 5 kgs. Now, suppose in the first second, in 1 minute, we should have got 235 kgs. So, but it has actually got 225 kgs. So, there is an error of 10, that is a shortfall. Now, if we select a proportional gain of 3, that means 3 into 10, 30. This will be multiplied to 225, and at the next second, the process value will go to 255. Similarly, the same example, now if the process value is 220 and the error it shows by subtracting is 15, and the proportional gain I have kept the same as 3, So the modification applied is 45. Now the result is 265. Now what is the change? The change is for an error change of 5, that is the error earlier was 10, now it is 15. Output change is 10. So that is what it is saying. That a high proportional gain results in large change in output for a given change in error. When the error has changed by 5, the output has changed by 10. So if the proportional gain is too high, the system can become unstable. The second, in contrast, a small gain results in small output response to a large input error and a less responsive or less sensitive controller. What does this again means? Same example, in this I have only taken the proportional gain instead of 3 as 0.5. Now the result has come, the same equation applies, 230 and 220. Now what is happening is that error has changed by 20, but output has changed by 10. So the response is less. Earlier the response was too much, now the response is less. So this is the factor, this is one of the factors, that is the A part. Now what does the integral part do? The integral part removes the error that has been occurring previously. In a sense, suppose in the first second, same parameters I have taken. In the first second, if 235 kgs per minute discharge rate is there, in the first second, theoretical emulsion flow should have been 3.92 kgs. But the actual flow is 3 kgs. So there is a shortfall of 0.92 kgs. In the second stage, it is 3.92 kgs, again it should have been, since ultimately the formulation has to be perfect. But it is going 3.22 kgs. So there is a shortfall of 0.7. So in the third second, what it actually is doing is that adding these two things up so that the error is eliminated, the previous error. This I am talking in respect of seconds, but it is actually happening in fraction of a second. That just for illustration purpose, I have taken it in second. What the derivative function does is that it predicts the future behavior and tries to keep the system in steady state. See, this is the equation. The first is the PID proportional. It is reducing the error. The second is the integral. It is reducing the previous error. And the third is the derivative. It is keeping the system to steady state. This is our set value, that is each of the parameters. This is a simple example. When we want the temperature to be 80, but actual temperature is 70, it sends a signal back that you should increase the heater output so that the temperature reaches 80. Now this PID controller controls each of our formulation pumps, that is the emulsion, GA and water pump, on an instantaneous basis, so that there is no change in the recipe, that is the formulation remains intact and blast performance is not hampered. This is a standard HMI. It has got certain features. Now what does the advantage, this I am telling the formulation part, it is done. Now the human part, what the human error can be minimized. The operator, instead of looking at all the parameters, has to only fix the discharge rate here and the set quantity, that is the quantity he wants to charge in that particular hole. All the other parameters are taken care of. So human error is virtually eliminated. Now what is the set quantity? Set quantity refers to the quantity of material to be charged in a particular hole in kilogram terms. We can always change the unit. Actual quantity is what the quantity is actually going, and what discharge rate is what is the rate that we are looking for. These are the buttons. F1 button is used to navigate the screen. F2 button, I will explain each of this. This is the F2 button. Now what happens is that this is an additional feature. Suppose an operator in a particular hole has charged 100 kgs and after the day's work he wants to charge some more. Here he can do the additional amount in that particular hole. He can set the hole number and the additional amount of kgs so that he can go back to that and do the charging. And the log for this is also stored here. Here I have told the discharge rate can be selected from, and this can also be adjusted based on the client's requirement. Now recipe is actually the formulation. This is done previously and the operator and is password protected. So the operator has no chance of modifying it unless he has the password. Here the discharge rate is fixed. The set quantity. Now what does the calibration do? The calibration is that before going to the mines, we do the calibration, that is the physical quantity matches with the actual quantity which is showing there. If there is any variation, we calculate it. Here set point. That is, if in that example, if the discharge rate is 350 and it is 94%, then what is the set quantity is 94. So what is happening is that set point. This is for each pump. That is, the set point is the quantity which you should have arrived. The process value is the instantaneous value, and the output value is increasing and will reach the set point. Here, this is the main factor in the PLC. I told the gain, the integral time and the derivative time. That is the PID that I am talking about. If the system doesn't matches with the process value, we do a calculation and do the scaling factor so that the physical amount and the actual amount matches. Same is done with gassing. Loop control, the total system is run and each one has its own set point and process value. And there is also a feature called additional set point. If somebody wants to change the formulation for a particular hole or for a particular, he can change the formulation by adding 1 or 2 percentages. These are it shows the emulsion pressure, emulsion temperature, everything is safety controlled. Now what does the setting have? Setting is, in setting we can store the emulsion high pressure, low pressure, high temperature, low temperature. These are the safety parameters. Once the system temperature or pressure exceeds or shortfalls its limits, the system will automatically cut off. Totalizer is it manages the total quantities and we can always keep a log. There is an advantage of having a pen drive or a memory card and the logs can be clearly taken how much is that. Now alarm. This is the most important part, that is the system error, how it is removed. This is actually in a normal straight emulsion, what are the interlocks that we are having. If emulsion pump is going for a high pressure, it will stop. For a low pressure, high temperature, it will stop. For a low pressure, it is stop. Even if the material is not flowing and the pump is rotating, there will be a heat generated.
Mr. Mitra, you will get 2 more minutes.
Yeah, sure. So even if the pump is rotating and material is not going out, there will be an increase in temperature. So pump movement field will cut off the system in case material is not flowing for 10 seconds. This is user password protected completely. Now the advantages to reduce operator dependence I have told earlier. Proportional, the system pressure trips increase, that in case of abnormal increase or decrease of pressure, the system automatically cuts off. Pump timeout trips ensure that in case of any valve is closed or there is blockage, the system will cut off. Pump movement trips ensure system is cut off in case of pump rotor jamming or motor not rotating. Low quantity level of pumps prevent pumps from dry running. Dry running of pumps will result in heat generation and thereby increasing chances of hazard. Charging data is continuously monitored and available in log, therefore chances of misuse is minimized. Any issue in BMD where the fault is occurring can be addressed easily because the particular alarm will indicate which part of the BMD operation should be addressed in case of malfunctioning. Thank you for giving me an opportunity.
Thank you, Mr. Mitra, for giving the very good thoughts on the PLC and use of PLC in the BMD systems. And the best part, you have refreshed our memory on related on the PID. You have given very good thoughts on starting from all the three gains, KP, KI, and KID after a long time. I think most of the audience sitting in the room is away from a study from last 15, 20 years. So you have given very good thoughts. Thank you, Mr. Mitra. So now the next session is for the question answers. So I'm really thankful to all my speakers who has maintained the time schedules and given very depth thoughts on their individual subjects. So now I will request audience to ask the question to our speakers. Yes, please.
Hello. My question is to Dr. M.K. Patel. In his IMS, he has shown a report as due diligence report by external agency. Sir, can we have a upgrade on this? What is that exactly? Due diligence report?
When you plan for some new activity, let us say that we are planning for a new plant or a new magazine. In that case, like what we call as an impact assessment study. That entire impact assessment study has to be carried out. So water, air, releases, natural resources uses. So how does, what is the base values, and when you carry out this activity, what will happen to that area? Like in terms of, mostly it is natural resources. How are you going to contaminate this? If anything, any discharges are taking place, both in the form of liquid or gases, how are you going to control it? At the first place, you should not be polluting. Even if it happens, then how it's going to be controlled? So basically, it's a big study they do, not many parameters they take.
So this is a one-time study only?
It's not in one, study is one time, but then periodically one has to really see that how it's getting affected. Supposing that you say, I would like the base, let us say about water contamination. If water contains certain parameters, metallic parameters, chemical parameters, what is the level now? And you claim that after 10 years, these parameters will be in this level only, or it will not be going beyond what it is now. So every year you need to test that and say that, yes, I am not polluting. So it's sort of actually corporate social responsibility, number one, you take. Number two is that, like IMS, you are taking care of the environment. So it's more like initially you clear the legal part of it, and then it's the moral part of it. How seriously, how diligently you are doing it.
Okay. Thank you, sir.
Thank you, Mr. Patel. Any other questions? Yes, please.
Hello, I'm Pangal from Caltech Energies. The question is to Dr. Thakur. The presentation was extremely interesting about the compartmentalized magazines. What I want to know is whether this is now accepted as a new standard anywhere in construction and design and implementation, and what is of relevance is I understand that the explosive rules are now under revision, or maybe in some time or the other it will revise. Whether we have any standards and new adopted or accepted standards for implementing in the new system, the distances. Yeah.
Actually, sir, when initially we were making the design, and then after we are conducting the validation trial, because it involves life, and just after design and this process, we can't get it inducted into the services. Then after the validation trial, witnessed by all the three services, Army, Navy, Air Force, and after broad discussion on the results achieved, this magazine, this type of magazine, high performance storage structure, has been inducted in the, has been forwarded by the storage panel, and it has been inducted into the stake pamphlet. So now it will be given to the services, and initially that igloo and URP based structure that were also approved and accepted by the storage panel. And for your information, more than 400 to 500 magazines like igloo has been constructed in India, and this HPM has still till not constructed, but it is in the process. And as it involves some greater risk, it has to be constructed in the forward area only. So that is why we haven't get any type of that proposal. And whenever we will get, as it has been included in the storage panel, it can be constructed.
Mr. Thakur, can I add to what you already said? Mr. Pangal, may I have your attention, Mr. Pangal? Yeah. Basically what they do is they have a stack pamphlet, and it's specifically for the defense. The construction details that we have in the explosive rules are different from what they have in defense. And we cannot straight away copy their design because it's been patented and it's meant for the defense. We have our own separate distance tables. If you take the distance tables which are followed by the defense, it's much, much higher. Like for any burning ground or laboratory or any facility, the minimum distance that they specify is 275 meters. Even if it's 5 kg from the process building, you have to maintain something like 275. For the LRC magazines that he was talking about, there is a stack pamphlet, but that's the property of DRDO. So that's how things stand. But we are still in the process of amending the explosive rules, and we have brought in certain changes. But these magazines per se at this stage cannot be copy-pasted into the industry as such, because there would be other legal issues. I hope it's loud and clear.
Yes, it is loud and clear.
It is actually intellectual property of DRDO.
Yeah, it is a property of, but it can be the inspiration for changes in future.
Would PESO consider this point? Yeah, because the land is a real big issue everywhere, more so in the eastern India. So if this idea could be implemented.
No, what? I mean, this is the platform where we can share our ideas. And in fact, we are very fortunate that we have someone from CFES. I was discussing this with the director of CFES, and I said, why don't you send one of your scientists for this seminar so that we can share our views. And in terms of distances, the distances specified in the explosive rules are considerably less than what they follow. Even with the reduced safety distances for these magazines would be much higher than what we have in the present explosive rules. The distances that we follow in the explosive rules, we go by the category. Your category X, Y, Z, and the ZZ. So the table does not contain Z. Most of the military explosives fall under category Z. And if we were to adopt the distances that they follow, then probably the distances would be much higher. And considering the land constraint that the industry has, and if you take the high tension lines that we have for our magazines, we prescribe 90 meters. In STEC, it is minimum 120 meters or 1.5 times of the OSD. I don't think any of you would be able to run your factory with 1.5 times of the OSD with a high tension line. There are factories in which the high tension line runs right through the factory. So maintaining 1.5 times or 120 meters is a big ask. And most of the explosives that we have, the categorization, as per the UN classification, it's falling under 1.1. And 1.1 has huge safety distances. And 1.3, we have very little explosives, barring the propellants, everything is coming under 1.1. And replicating everything from the stack, what we are trying to at present do is, for the defense explosives, whatever proposals we are getting, we are trying to implement the stack pamphlets, whatever is there in the stack pamphlet, like for the construction details, we are following the stack pamphlet 3. Whatever is there in the stack pamphlet 3, anyone who intends to manufacture propellants or defense explosives, the construction of the building has to be as per stack 3. And the distances, including the distances for the high tension line, we are taking it as 120 meters or 1.5 time of the OQD, whichever is available. So that's how it stands, and it's a platform where if it's a concession which can be given to the industry, but at the same time safety cannot be sacrificed. And what he was talking about, the unit risk, that's already there in the explosive rules. But considering the safety consciousness or the level of awareness that we have in our industry and the work culture, we really need to upgrade ourselves before we can accept their norms. What is the work culture? They have got in defense full-fledged research laboratories where they do work. And in our industry, barring a few manufacturers, none of us have a R&D lab. It's primarily copy-pasting, or a person who's working in industry X, he migrates to Y, and along with him, he takes the formulations or the distances. So the challenge in the industry is something different, and we cannot straight away replicate what is there in defense. Plus, if you take the recent incidents in Pulgaon, there has been an accident, there have been casualties, and now we're shifting over to the defense explosives. It's not that we always look for concessions in distances. I mean, concession really doesn't serve the purpose at the cost of life. Safety is of prime importance, and we have to see how best we can match our intent with the present circumstances. So that's how it is. Safety should be the priority. I hope it's clear. Thank you.
Thank you, sir. Thank you for providing the clarity on this subject. Any questions? Yes. Yes, ma'am.
Hello. My question to Mr. Mitra.
Mr. Mitra, yes, please.
Yes, we have 2 BMD vehicles with PLC fitted.
Yes.
And the experience is very good. But we are facing some problem in field.
Okay.
And actually PLC is working on the basis of sensors and
Yes.
meters. So sometime the meters and the sensors got damaged.
Okay.
And damaged, or I could say some problem during charging. So at
Okay.
that time the vehicle could not run. So what is the improvement you are going to implement in the future?
Actually, what we have gone through is
In worst condition, rough condition.
in rough conditions, there is an alternative in two. That is, what we are doing is a PLC come manual operated. So, if the PLC manufacturers or since some sort of problem in the sensors arises, because it is an electrical equipment, it is bound to have some problems in the long run. So, instead of coming back, they can do the manual charging, come back to finish that days of charging, and then come back to the location, base location, and rectify those error. Because in the mining site, it will be difficult to rectify those error at that. But the charging can be completed so that there is no financial loss, and then come back to the site, and then we can address those errors.
Okay, they are charging manual. Okay, no problem. But only thing is ki they try to continue with the manual operation. So
that has
why? Because they are not getting immediate solution of it. So if they are not getting immediate solution, then they will continue with the manual charging, and it will keep on going.
that means the quick response of the rectification of the problems that you are looking for, right?
Quick response plus the robust system.
Okay, robust system. Okay, robust, I guess I can address those issues, but quick will definitely, in terms of service, we can provide that quick service. But on the days front, that charging has to be completed and come back, and then the address can be issued off-site, not on the on-site. Definitely.
Thank you.
Last minute. Anybody had any questions? Last question from the audience, by considering the time. Okay, so no questions. Thank you. And once again, I will request Dr. Kamal sir to give this type of opportunity for interacting the sessions between all the explosive manufacturers and the all other the fabricators, the vendors, and the suppliers which are directly associated or indirectly associated with this explosive business. I will request to give considerations for giving the more attractive sessions. Currently, we are doing the Explosafe after a frequency of the 3 years. If you can consider, say, frequency of the within 1 year or 2 years, not as such a big Explosafe, but is a smaller shape that will give more opportunity to the explosive manufacturer to understand what is happening in the other industries, what are the best practices available in this field. So that is only my request from Dr. Kamal and the associations which are conducting these sessions. Thank you. Thanks a lot for giving the attention for these sessions.
Thank you, Sri Rakesh Kumar, for chairing this session for us, and also the speakers for coming up and presenting their papers today. I would request our chairperson, Sri Rakesh Kumar, to now present mementos to our speakers from this session. So, first would be Sri M.D. Trout Consulting, South Africa. I would request Sri Kumar to present the memento. Dr. M.K. Patel, Ideal Explosives Limited, Rourkela. Dr. Prabhanjan Thakur, Center for Fire Explosive and Environment Safety, DRDO, Delhi. And Sri Sanjit Mitra, Associated Engineers, India, Nagpur. Thank you, Sri Rakesh Kumar. And now I would request Mr. Shekhar Kumar from Black Diamond Explosives to present the memento to our chairperson for this session, Sri Rakesh Kumar. Thank you, Mr. Kumar, and all the speakers for this session. Ladies and gentlemen, we will take a tea break here. It's a 20-minute break. I would request everybody to adhere to the schedule. And I have a couple of announcements to make. So before you step out, just to request all contributing manufacturers to collect their mementos on behalf of your company from the room next to the conference hall. The memento can be collected any time after this session till the valedictory session. So kindly collect your mementos before the beginning of the valedictory session. I also request each member to collect only the memento on behalf of their own company. I would request Shri G.K. Pradhan to meet Mr. Dikshit near the stage management. And as I announced yesterday during the entertainment phase that some folders and kits have been misplaced, we found a couple of them. I would request Mr. V. Agarwal to come to the stage on the right-hand side and identify if the kit belongs to him. And if anybody else has misplaced their kits, they can come forward and have a look at the kits that we have. We have found 2 kits. Next session speakers, I request you to please come and meet the stage facility here on our right-hand side to facilitate and make it easier for your session to begin in the next session. Thank you. A reminder.